There you are. So, you want some hints and tips on how to come up with a really good password, do you? Well, if you're willing to listen to me for a few minutes, I'll give you a few good pointers. So to show you how you can come up with some better passwords that are easier to remember and harder to crack, I'm going to run you through my Forgot My Password presentation. So to give you an idea of how useful these techniques that I'm going to show you can be, I reckon by the end of the presentation you'll be able to easily remember this 17 character password. It looks complicated, most people would never get it, but I reckon by the end you'll easily have it. So we all know we need passwords, and we all know that they've got to be longer and they've got to be difficult to crack, and we need it to be a password that people can't recognise when they spy over our shoulder and things like that. So what I've done is I've put together a few of my little musings, and hopefully these will help you to come up with a better password that you can easily remember but people won't get. So there's a number of ways that hackers will try and gain access to an account, and they'll use your email address, which is typically fairly commonly available, and they'll use passwords that they've nicked from places like LinkedIn and that, and people that have had data breaches, and these tend to end up on lists, and people use passwords that they've acquired and email addresses that they've acquired just to try and randomly gain access to different websites. So from time to time, if you've ever had one of those emails that says, oh, your password's trying to be reset, click here to reset it. This is probably what's going on. There's people out there that are trying to access your account using your email address and random passwords. So it's important to come up with a password that's not going to be on one of the lists, so that they can't try and use these types of attack to gain access to your stuff. So the first sort of password that most people are familiar with is your PIN code when you make a purchase with a debit card or a credit card or with your phone. It's typically 4 digits, 0 to 9, so you've got a 1 in 10 times 4. So essentially the odds of guessing somebody's PIN code right first time is 1 in 10,000, and that's not bad. Now, some banks will let you have a 6-digit PIN, and if you can do that, then you should, because the odds of getting that right aren't 1 in 10,000 anymore, they're 1 in a million. So that's 990,000 more combinations to guess. So if someone gets your debit card, tries to steal your money with a brute force PIN attack, and guessed every 2 seconds, 24 hours a day, 7 days a week, it'd take them about 23 days to gain access to your bank account. But if somebody used a decent computer to do the same crack, it'd take about 0.3 milliseconds for them to gain access. So being a good engineer, I've made some calculations and I've put together this little table to show you how long it'd take to crack a PIN number made of digits only, and how long it'd need to be to make it worthwhile to have. So to have a PIN that's worth having, that's difficult to crack, you're going to have to get it up into about the 19-digit range, but that's hard to remember. So PINs, by the nature of being short number of digits, they're really easy for people to remember when they spy over your shoulder, and on that basis you really shouldn't use a PIN to secure anything unless you really have to. So to increase the difficulty of cracking a password, we need more complexity, and we do that by adding more range of characters. So adding 26 letters, or 52 if we use uppercase as well, and all the special characters as well, we can get to a character set that's about 128 characters. So having this much larger range of characters now means that guessing a 6-character password is a lot more difficult. We've got 1 in 128 chance of getting each character right first time. So now the odds of getting it right are something like 1 in 4 trillion. This means that the odds of getting it right first time now are so slim that you're more likely to win the lottery. This means that it's actually more profitable to gamble than it is to try and guess somebody's password. So I decided I'd make this little password strength calculator in Excel, and you punch in your password and it tells you how long it's going to take to crack. And this 6-digit password, even though there's so many combinations, it's only going to take a computer a shade under 21 minutes to crack. So clearly we need to do something a little bit better than 6 characters. So what we need to do is increase the length of the password by adding more characters, and we need to use special characters and numerals as well, so that it's more difficult for third parties to remember and it's more difficult for a brute force attack because we're not on a standard password list. The other sensible thing to think about here is tempering the length of the password that you're using according to the value of the information that you're trying to hide. So longer passwords use for greater security. Don't use common words, don't use ones and exclamations at the end of a word, don't use your birth details, don't use linear keyboard patterns or simple words, don't use stuff that people can look over your shoulder and see. You'd be surprised what people use. And I've put some of the more common passwords here and you can see how ludicrous some of these things are. So back to the password strength calculator, and I've punched in orange 1 exclamation. I've done exactly what I've told you not to do, but adding those 2 extra characters has made a significant difference to how long it takes to crack the password, now over half a year. So this is really the minimum length of password you should consider. One of the easiest ways to pad out the length of a password and build up the number of combinations is by using multiple words, but be careful using words because they genuinely don't pass the spying over the shoulder test. I'm a bit of a car nut, so I might choose Lamborghini, Porsche, Ferrari as a password, and the odds of guessing a 25 character password right first time are now so substantial it's impossible. It'd take 425 decillion years to crack that hard crack, but it doesn't pass a spy over shoulder test. Somebody'd get it in a minute. So here we are with the password strength calculator again, and you can see it's actually quite a decent length password. It is quite long at 25 characters, and it is 425 decillion years to crack. But if somebody watched over my shoulder, they would, after a few views, have that, and it wouldn't take 425 decillion years. So a good way to come up with a password that's difficult for the over-the-shoulder spy is to make an initialism out of something, like for example TU2WOTD. That's derived from Tommy used to work on the docks. It's not easy to remember for other people, so we're halfway there, and if people were looking over your shoulder to try and remember it, they'd be living on a prayer. If you want to learn a bit more, take my hand and we'll make it, I swear. But that's still only a 7-letter password, and a computer would crack that in about 1.8, like just under 2 days. A computer would hard crack that. So obviously we've still got to make our password longer and add more characters. So if we just pop Tommy's password into the password strength calculator, we can see that we are looking at 1.82 days for that. So it passes the over-the-shoulder test, but it's just not long enough. We need to figure out some way of making the password a little bit longer and making it a little bit more secure. So initialisms make it good for the over-the-shoulder spy, and so does character swapping, and that's basically where you use @ for A's and 7's for T's and stuff like that, and I'll show you what I mean in the password strength calculator. I've popped the start doing this password into the password strength calculator, and look at that, 2.8 trillion years to guess that one. I think we might be getting somewhere. Another technique you can use is case swapping, and that means you have to tap the keyboard a few more times as you swap from lower to uppercase, and that can make it more difficult for people who are trying to count your keystrokes to figure out how long your password is. So we've learnt some good techniques here with the case swapping, character swapping, and with initialisms and things like that. But there's one really good technique that I'm going to teach you now, which is absolute gold. Now when you look at your computer keyboard, you'll see that at the right hand end there's typically at least a couple more keys after the letters which you can make use of in your passwords, and we can make use of these using a technique called offsetting. So in the example we've offset a lowercase p 1 key to the right to get a square open bracket, or 2 keys to the right to get a square closed bracket. Basically offsetting is exactly that. You think of your 2 or 3 word password, you add in a few special characters here and there, and when you type it in you offset 1 or 2 keys to the right so that the password that you enter is complete gobbledygook, and anybody who's looking over your shoulder would never in a month of Sundays decipher what it is that you've used for your password. But you yourself, you know what it is, and it's easy to remember. So to demonstrate what I mean here, we go to the password strength calculator, and this is the word offsetting entered into the strength calculator, but I've offset the word one key to the right when I've entered it. And you can see that I've come up with a 10 character password that would take 10,480 years for somebody to brute force crack. Nobody would ever get that by looking over your shoulder. And if it appeared on a password list somewhere, it wouldn't mean anything to anybody. Offsetting will give you new, unique passwords that pass the over-the-shoulder test and pass the strength test. But unfortunately, we still are missing some of those special characters that we need. So maybe using this with an initialism or with some character swapping will give you a really secure password that you can easily remember. So if you come up with a password like this, it's unlikely to appear on a password list, and if it gets skimmed, it's going to be gobbledygook. What it means is that people, if they're going to hack your accounts, they're going to need to use brute force cracking to get in. And if you've got a 9 character password, it's going to take about 80 years for someone to crack that password. One good way that you can come up with passwords is using specialist knowledge, and if you're into chemistry, you'll understand what this formula means. I had a mate at school who was excellent at chemistry, and I used to copy his homework all the time. Hello, Kingy. But look at this. I mean, we just punched this password into here. It's a straight acid plus base equals salt and water, 17 characters long, and 755 quintillion years to guess that. If someone saw you type it in, again, they'd have difficulty understanding what it was. Here's another little example for a password. The mathematicians and the engineers amongst us might recognise this one. It's entered into there, it's come up with 11 characters, and it's a 1.3 million year crack for that. So if somebody was spying over your shoulder, they might, after a few goes, get an idea of what that was, but it's got some special characters in it, it's got numbers, it's got letters, uppercase, lowercase. A password like that, or a password like the chemical formula, offset 1 or 2 keys to the right, you'd have a cracking password, easy to remember, nobody'd ever get it. So generally people want to try and hack into your accounts for financial gain, and this is an interesting fun fact as well. Like if you had a 128 character password and you wanted to brute force attack it, the power needed just to switch the processor on and off, without the motherboard, the cooling system, the monitors, the keyboards, without anything else, just turning the processor on and off requires 30 gigawatts of power. And that's about 0.1% of all the energy produced in the world in a year, and the value of that energy to crack the password is about $7.5 million. So if somebody wants to spend $7.5 million to rob me of $50, they can go for the life. Now, we said earlier on that you should temper the length of the password in order to protect the value of the data that you're trying to hide. So a 10 character password should be pretty good for most circumstances. 14 characters would be better for things like banking, and a 15 character password would take 360 trillion years to crack. So I couldn't help myself, and I've had to crack out another table of time required for brute force cracking of different length characters, and this one's for the 128 character set now. Now, the thing to bear in mind with cracking passwords is that if someone's going to have a hard crack at your password, they don't know how long your password is, so they've got to guess all the lower numbers of combinations first. So they'd have to guess all the 1 character passwords, all the 2 character combinations, all the 3 character, and so on until they get to where you are. That means that there's more and more possible combinations to check before they can move up to the next number of character sets to get to the next level of password to eventually get to where you are. So that's why it's a non-linear progression in terms of how long it takes to crack. You can see there 10,408 years for a 10 character password, and the more characters you add, it goes up significantly quickly the time and effort required to make the crack of the password. So looking at the fun facts again as well, if we had a 13 character password, 22 billion years to crack, the Earth's existed for about 4 billion years, and it'll be around for about another 8 billion till the sun swallows the Earth. And the universe has been around for quite a while as well. It should last for about another 30 billion years, so a 13 or 14 character password should be long enough. So the final tips then are to come up with a few passwords that you can use for different things. Use specialist knowledge if you can, like the chemical formulas or the mathematical equations. Make sure that you use character swapping, make sure that you use upper and lowercase and special characters, and make sure that you use offsetting. Don't store passwords in password managers and browsers, that's a bad idea. Create your password, use offsetting so that over-the-shoulder spies can't understand what you're punching in and make it difficult for everybody except for yourself. You can do the offsetting by using one key to the right, two keys to the right, or patterns of 0, 1, 2, or to the left or up or down or whatever. Come up with a password that's at least 10 characters and 2 words, and use special characters and use offsetting, and you will have a pretty decent password. What I'm doing here now is, just for the last time, just for a laugh, I'm putting the forgot my password into the password strength calculator. And you can see here that it's a 17 character password that would take 755 quintillion years to crack. I reckon that's a pretty decent password. So you remember at the start I asked you if you could remember this password. Well, I reckon you probably can, because if you take the title of the presentation, forgot my password, and you retype it in but offset it just one key to the right, you get the password that I want you to remember. I bet you could remember it now, couldn't you? Trouble is, I can't use that one now though, can I?